Welcome to Emilac Online Tutorial. Now before us, now is this exponential equation, and we were wanting to use the Lambert W function to resolve this equation. But let us recall that according to the Lambert W function principle and rule, now for we to apply the Lambert W function, that expression will take this pattern so that when we plug in the Lambert W function, or we apply the Lambert W function, it gives us A. Okay? So our goal in this equation now is to resolve it to, to this pattern. Alright, so how then do we start? Now first of all, let's take x to the right hand side. We end up having 2 raised to the power of x equals what? 5 minus what? X. Okay? Now let us just switch the sides. We have 5 minus x equals what? 2 raised to the power of what? X. Now let's divide both sides by 2 raised to the power of x. So here we have 5 minus x all over 5 minus x all over 2 raised to the power of x equals what? 1. Now this part of the equation can also be rewritten as 5 minus x times 1 all over 2 raised to the power of x equals what? 1. Okay? Alright. Now let us take note that according to the law of indices, if you have 1 all over x raised to the power of n, same thing as x raised to the power of minus n, right? And if we have 1 all over x, it is same thing as saying x raised to the power of 1 minus 1. Let us now apply this rule. Here, we end up having 5 minus x, then into 2 raised to the power of minus x equals 1. Alright, now looking at this also, I guess we are coming to, a situation whereby we get that kind of argument. But something is shaking here. Now, here we have negative x. Here we have negative x. Alright, let me switch this or rewrite it in this manner, minus x plus 5. Okay, so here we have 2 raised to the power of minus x equals what? 1. Now looking at this now, how do I add 5 to this exponent here? Because by adding 5 to this exponent here, it will now give the same pattern. That is, the exponent, the coefficients will be the same as the exponents. Alright, now let us come back to indices again. Take note that when we have x raised to the power of a times x raised to the power of b, this can give us x raised to the power of a plus b, as long as they have the same base. Okay? Alright. So which means if we look at this principle rule, it means for me to include plus 5 at the exponent here, I will need to multiply both sides of the equation by a base that is 2 with a power of 5. Okay? Now by so doing, we can say minus x plus 5, then 2 raised to the power of minus x times 2 raised to the power of 5, then equals 1 times 2 raised to the power of 5. Now which implies that this expression here is the same thing as this rule. So let us apply this rule here. So here we have that minus x plus 5, then times 2 raised to the power of minus x plus 5 equals what? Now 1 times 2 raised to the power of 5 should give us 32, because 2 multiplied itself in 5 places will give us what? 32. Okay, I guess it's beginning to look like it. Alright, now but there's something missing. Our e is missing. So W function deals with e and not with just a number like this. Okay, so how then do we do it now? Let us come back again. Now if you have e to the power of ln x, it gives us x. Okay, so which implies that this is a rule. Okay, now if we change x for 2, so you put 2 here, put 2 here. Now it looks as if now we've introduced our e into this. So let us apply this rule. So instead of writing our 2 here, let us represent it with what? E raised to the power of ln 2. So here we have minus x plus 5, then e ln 2, okay, take note, raised to the power of minus x plus 5, then equals 32. Okay, and let us recall from the power log, that when you have that log a raised to the power of n is same thing as saying n log a. Okay, similarly, ln a raised to the power of n equals what? N ln a. Now, applying this rule here, now we get to have minus x plus 5 e, then minus x plus 5 ln 2, then equals what? 32. Alright, now but it look as if we are not yet we've not yet arrived completely to this kind of argument here. So alright, now here we have minus x plus 5 ln 2. Now but here we don't have ln here. Okay, so what we do now, we multiply both sides by ln 2. So by multiplying both sides, we have minus x plus 5. Now ln 2 e raised to the power of x plus 5 ln 2 equals 32 ln 2. Okay, now at this point you can see that we've gotten this expression here, okay, by the right hand side. So what we need to do now is to plug in or include what? Introduce the Lambert W function, that is w. Then here you have minus x plus 5. Now ln 2 e minus x plus 5 ln 2, okay, close bracket, then equals w into 32 ln 2. Now, according to the rule, we have a, so the term here and the term here are the same. So we end up having minus x plus 5 ln 2 equals w into 32 ln 2. Now what we just need to do here now is what? Divide both sides by ln 2, this to ensure that we are drawing closer to the x, to the coefficient I, to making x the sort of relation. Then we eliminate. So here we have minus x plus 5, then equals w into 32 ln 2 all over ln 2. Alright, so we end up having here minus x plus 5 equals w 32 ln 2 all over ln 2. Alright, now to this end, what we just need to do here to make it more simpler, I just take, since we're making x the sort of formula, let us take 5 over to the right hand side. Here we have minus x equals minus 5 plus w 32 ln 2 all over ln 2. Now, to remove this minus sign, let us multiply both sides by minus 1. We end up having x equals 5 minus w into 32 ln 2 all over ln 2. Final answer. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.